Alright guys, so I want to talk about this last LED driver we have here. If you remember from the previous two videos, we talked about two other kinds, which are right there. You can go watch that video if you want to see how that turned out using those. But this last driver here is a little bit different than those two. Those two were constant current out at 300 and 350. They were non-adjustable. It basically regulated the voltage automatically based on the amperage needs of the chips running at 300 or 350 milliamps. So this one here is actually totally adjustable, both voltage and amperage. So basically what that means is I have the power supply set at 14 volts. Here we're monitoring the voltage of the driver, the output, and here we're monitoring the amperage. So with that being said, if we look at this driver, you gotta forgive me, I'm running a ad hoc external battery set up in the Sony A5100 to see if it helps with the overheating issues. So we'll see what happens. So what's nice about this driver again is it's adjustable. So as you turn this dial, you ultimately affect the output of the voltage. So if you turn to the right, it goes up. If you turn to the left, it goes down. So I believe with this driver, you can ultimately set any voltage from 1.25 to 36 volts. It's only a step down driver, however, a buck converter I think they call it, meaning that you can only drop the voltage down from what you're supplying. You can't boost it. That's a totally different type of driver. So anyway, we'll go over the driver, basically getting a power source like a car, anywhere from say 12 volts to 15 volts, and you can see no matter where I adjust this to, the voltage is always the same coming out of the driver. Alright, so how about we hook up an LED here. So basically we're hooking up one chip, therefore we want to keep the voltage at what that chip requires, which is 2.4 volts. I've already dialed the amperage dial down, so we're not going to blow the chip out or anything. Although I don't think you would anyway if you have the voltage set at 2.4. It would take time to heat up. So that being said, we'll monitor the current and I'll show you adjusting that as well as what that does to the chip. Alright. Move the camera over here so you guys can see that. Alright, so you see here, hopefully, we're running at 308 milliamps going through this one LED. And remember, these are the amber LEDs that can run on 2.4 volts, which is what we had our voltage output set to. Anywhere from 400 to 500 milliamps. I currently have it dialed down to a constant current of about 300. So as we turn the amperage dial now, you see what happens will be turn it down, and you see now we're at 290, 280. If you see, the LED is actually getting dimmer and dimmer because we're basically restricting its current consumption. So there at 20 milliamps, it's barely glowing. If we drive it back up to 250, 350, 450, 420, 430. So there it's basically running at its full power consumption. I'll grab the camera and show that again just in case you weren't seeing it. But basically there's how we basically are regulating both the voltage and the current on this LED driver to perfectly accommodate one LED chip. And it doesn't matter, I'll fluctuate the power source here from 12.5 to 15, and you can see that the numbers stay the same. Alright, so with that being said, you can literally dial in any amount of LEDs that you want to wire in your array or DRL strip or what have you. All you have to do is calculate the requirements you're going to need. So if we're wiring all these in series, we have, say, 3 we want to wire. We'll have 3 at 2.4 volts. Doing that math, you're at 7.2 volts that would be required for the 3. Still at the 400 to 500 milliamps. As you can see, I've dialed in the voltage adjustment to the 7.2 volts being outputted. The amperage was still left at the 420, I believe it was. So when we now provide power to these 3 chips, they're all glowing at full brightness, pulling the required 430 milliamps that we are limiting the current to. And again, it doesn't matter if you're at 15 volts, 12 volts, it's all going to stay regulated, running at this requirement. Now, that brings us to the second point. We can drive 3 LEDs. If you remember the other video with the other 2 drivers that we went over, that again, those 2 drivers worked and operated on an output range of, anywhere from like 9 to 12 volts or something like that, and the voltage self-adjusted based on the amount of LEDs you wired in series. But if you remember, those 2 drivers, basically for automotive applications in a charging system where the voltage is going to fluctuate from the source between 12 and 15 volts, you really could only wire in like 4 or 5 LEDs. So with this one, we know that we can wire in as many or as little as we want to a point. What I mean by that is, remember, this is a step down driver, not a boost driver, and we need to manually set the regulated values. That's going to run like that 24/7. So with that being said, running the 3 LEDs here requires 7.2 volts, and we set that. If we want to run more than that, say 5, 6, 7, that's going to be a higher voltage than what your 12 volt battery can potentially be putting out. Now when the charging system kicks in and it's say 14.5, 15 volts, that gives you a bigger margin of LEDs to work with, but it's not always going to be running at 15 volts. Obviously, your charging system is going to kick on and off, so we got to account for that. So with that being said, if I tried to wire in say 7 LEDs in series here, we would need to dial the voltage here on the regulator to 16.8 volts. And again, even with our charging system at full capacity in the car with the alternator running, you're probably only going to ever see a maximum of 15 volts. So we still wouldn't have enough voltage to drive the 7 LEDs. Definitely not enough that they would barely glow when the car is off and you're dwindling down at 12.6, 12.4, 12.1 volts on your battery. They would barely light up. So one way to get around that is you just wire them in series and in parallel. So how we do that here is we have our 3 in series, which is our 7.2 volts, which we should technically always have because that's your 12 volt battery or your 15 volt reading when the alternator is running. So we can always step down from that source voltage down to 7.2. But again, we can't step up to anything higher than the source. So we're going to keep the voltage dialed in at 7.2 volts for these 3 LEDs in series. We're then going to wire the next 3 in parallel to that, meaning the voltage stays the same, the requirement of the voltage stays the same, and all we'll have to do is double the amperage. So let's keep the voltage at our 7.2, which it is. We're currently at 12.2 volts from our source power supply, aka the car. And let's see what happens when we hit power to these 3 in series, and then these 3 connected to those 3 in parallel. So you can see they're pretty bright. We're reading our 430 milliamps on the meter there. However, if you heard me say we need to double the amperage because of these connected in series to these. So these LEDs are actually only getting, they're sharing that 426. So to actually make each one of these glow at their destined brightness, their full brightness of say 430 each, we got to dial up the current regulator here to like 850. We'll stop a little short, but so you should be able to see them getting brighter. Hopefully, we're out now 700, 750, 800. So I'll dial it back down, and you can see them dimming back down at 430. So that's basically how you would get around to wiring multiple LEDs where the voltage requirement of all the LEDs in series is higher than what your 12 volt to 15 volt source would be. And right now I'm adjusting the source voltage from 12, 13, 15, and you can see there's no fluctuation in brightness or anything because our driver there is handling and keeping the output voltage and output current where we want it.